Hi, I'm Joe Morefield. I'm here to talk about the differences between the 55 series PAs and the GRF56 series PAs, and just give you a general overview of the differences. Mainly the performance. The 55 series PAs are a good solution if you're looking for high gain, high efficiency, um, whereas the 56 series PAs are basically the bigger, tougher, more powerful version. You get a little more PSAT, a little more P1dB, a little less efficiency because it's significantly more current. But what's great about them is that they're pin-to-pin compatible. So if you, let's say, start out with doing a layout for a 5509 PA, and then you decide later you want a higher power version of it, all you got to do is drop in the 5609 and you'll be good to go. So that's one of the interesting things about the 56 series footprint. So one thing interesting about how we number these is it helps you figure out what frequency ranges they operate at. So for example, the 5604 PA operates in the 400 megahertz range. So the last two numbers of the part number is generally the frequency range. So for example, the 5621 would be 2100 megahertz. 5521 would be 2100 megahertz. So that's a good way to kind of get a quick overview of what the frequency operating range is of these PAs. The reason we have many different PAs for different frequency ranges is we're limited by the on-die harmonic trap. We have down bonds that, we have limits to how big they can be or how small they can be. So that's what limits our frequency range. But usually we can tune up or down a band around what the PA was designed to do. So for those who may not fully understand harmonics, picture if you threw a pebble into a pond. After you throw the pebble into the pond, you'll see ripples at certain intervals. That's exactly what happens in RF. Let's say you have a 900 megahertz fundamental frequency. Because of parasitics, because of impurities, impedance mismatches, you're going to get reflections, and it's basically going to be like ripples. And that happens at predictable intervals. 2 times 900 megahertz would be your second harmonic. 3 times 900 megahertz would be your third harmonic, and so on. So that wire bond trap, it's basically a shunt capacitor with a wire bond going to ground. And as you tune that, it's going to affect gain, linearity, P1dB. It affects almost all the performance parameters. So that's a limiting factor in how far in frequency you can go with any given PA. The 55 series PAs are quarter watt, half watt PAs. They have a smaller transistor size, which is why we have lower current. The 56 series PAs have a larger transistor size, so therefore you have more PSAT, more power, but it makes it a little more narrow band. So it takes a little more tunes if you wanted broadband performance. But that's what we love doing here, is tuning on these PAs. We love being able to come up with new custom tunes that maybe the PA wasn't designed to do originally. So yeah, please reach out to us whenever you see a custom tune that might not be on the website for a given part. And we'd love to figure out how we can make it work for your frequency range if we don't already have a tune for you. So the 55 series and 56 series PAs, one of the differences I mentioned was current. 56 series PAs have about 100 milliamps more current than the 55 series because of the larger transistor size. However, you can tune on your current with the V-enable resistors. We offer external V-enable resistors. However, those are very sensitive for ACLR performance. So if you care about linearity, you'd want to do V-enable sweeps, voltage sweeps, to find out where the optimal linearity point is, and then you can adjust the resistors for that. And of course, we're always here to help you with that. We can guide you as to what what value resistors to use to get whatever performance you want. So if you want more power and you don't care as much about the linearity, then we can adjust for that. There's trade-offs. Or we can tune it for optimizing linearity, and then you have a little less power. So we're very flexible with the way we tune our PAs as to customizing them for your performance needs. Oh, and one of the little tuning handles that was surprising to me, obviously your output match caps, your choke inductor, those affect linearity. However, on most of our PAs, on pin 12 is a 0 ohm resistor going into feed the bias circuit. And I've noticed if you tune on that resistor, I've gone anywhere from 0 to 100 ohms, that can affect your linearity performance and give you a little bit better ACLR. So there had been some challenges with tuning these 55-56 series PAs. One that stands out to me was on the GRF5536, which actually covers 3300 to 3800 megahertz. As I was testing ACLR under modulation, we noticed that after 20 megahertz bandwidth, all the way up to 100 megahertz, we noticed ACLR performance dropped off. And so we had to fix that and redesign it to improve the all the way out to 100 megahertz bandwidth ACLR modulation performance. Other challenges, like I mentioned, the 56 series is more narrowband in its performance. So if you want a broadband performance and you don't care as much about P1dB or PSAT, then the 55 series version might be the way to go for you. Also, there's been challenges when tuning the higher power PAs, especially with mu. We might have a little dip that goes right below 1, and so we've come up with various fixes for that, and we can always share those with you guys when you reach out to us. But one of the important things to improve that is to make sure you have good ground vias underneath your part. We have many ground vias under our ground to not only reduce the inductance to ground to improve stability, but also for thermal reasons to keep the PA cool. So we measure all of our PAs over temperature. We usually go down to -40 and all the way to 105 degrees. And we do thermal scans. So we make sure that the junction temperature stays around 180 degrees or less. And if you ever have situations where you need a higher VCC voltage or anything like that, just get with us and we'll let you know if it can handle the temperature. So there are performance differences over temperature, obviously. As you run it hot or cold, you'll get more or less gain, usually around 1 dB or more or less. Current changes, basically all the performance changes a little bit over temperature, which I'm sure you would expect. So yeah, we can, in characterization, we always measure over temperature and we put it on our data sheet. So let us know if you have any questions about that. So specifically, as far as what parameters shift over temperature, gain, efficiency, P1dB are better at cold than hot, but linearity gets a little worse at hot. So that's basically the performance parameters that change over temperature. Something I'd want to highlight about the 55 series PAs are they're very linear. We're talking IP3s in the mid 40s, upper 40s. So that's very attractive about these parts. 56 series PAs are also very linear. You just get more power, usually around 2 to 3 more dB of power out of them. So yeah, they're great PAs. They're easy to tune on. Maybe there might be some unique differences from PA to PA depending on the frequency range that comes up with trying to match them. But again, we're here to help you with that. We've seen it all with these PAs. So, oh my gosh, I can't even count how many custom tunes I've done. It's a huge amount. We probably have around 10 custom tunes per PA, per part number. That's probably most of our favorite things to do, is tuning on these PAs and interacting with customers. So a lot of the common applications I've seen for these PAs for the 55 series and 56 series has been space applications, walkie-talkie two-way communication, air defense, automotive. We get a lot of applications in that regard for either using these as driver PAs or final stage PAs or standalone PAs. So oftentimes when trading off power and efficiency for linearity, sometimes it's as simple, depending on the part, as moving an output match shunt cap away or towards the DUT. Sometimes it's as simple as that. Sometimes it takes a little more tweaking of the bias, like I mentioned before, sweeping V-enable voltages to find an optimal linearity tune. Same thing goes the other way for optimal P1dB and efficiency.
Thank you so much for watching. If you'd like more information, please email us at sales@guerrilla-rf.com. And don't forget to subscribe to our channel for more content from Guerrilla RF.